Okay, so we're going to take a look at some of your basic Windows tools for troubleshooting and evaluating your network. So, and it's all for the command prompt because this is where you really need to have some familiarity. That's what's the same everywhere. That's what's easy to run remotely. The command prompt is what you're going to use. So let's take a look at, this is kind of our diagram of a typical network. And let me just... So our PCs are all connected to their respective switches with basic Ethernet cables. Now, and then this server is going to be connected over here to that switch. Our switches are connected to each other, usually through what we call a trunk line. And let's just say that a trunk line is a little bit thicker. You know, often like your connection to your devices is going to be, you know, like 1 gigabit Ethernet, and your trunk lines will be 10 gigabit Ethernet, although that's not strictly necessary. The key thing is that the trunk lines carry traffic from everybody. So our PCs are connected to our switches are connected to a higher level switch, and that switch is connected to a router, and then that router is connected to the outside world, what we're calling the cloud. We don't know how that works, we don't know what's out there, and we don't have to know for diagnosing our internal problems. All right? So first thing that happens is PC1, when you turn PC1 on, it's going to send out a request for an IP address. It doesn't have an IP address, and it's set up to use DHCP, Dynamic Host Configuration Protocol. So it sends out that request. The request gets to the switch. Now this is a broadcast request because it doesn't know what network it's on, so it can't send it to anybody. It just broadcasts it over the MAC address. And if you remember, the MAC address broadcast is FFFFFFF, 64 bits. So it gets to the switch. The switch knows not to the switch will broadcast it to all these devices, and including to this switch. This switch will broadcast it to everybody, and eventually it should get to the server. Okay, the server is then going to send back a response, and I'm abbreviating the process here. There's actually a couple more steps, but the server is going to send back a response. Okay, here is your IP address, right? The PC1 will accept it, and then it has an IP address. How do we view that IP address, that lease? Well, from the command prompt, if you type ipconfig, it will give you the basic information about your IP address. So it tells me what domain name I'm connected to. My IP address is 172.16.44.140. My subnet mask, and my gateway. So that is, when I have traffic that's leaving my network, that's the address it's going to go to. If I do ipconfig/all, I get a lot more information. So let me scroll up a little bit here. So I get some of my local configuration information, including the name of my computer. I get the Ethernet information, the description of my Ethernet connection, the MAC address, the physical address of it, that DHCP is enabled, my IP version 6 address. We're not talking about IP version 6 right now. We're kind of ignoring that, but I get that information here. My IP address, my subnet mask. Now, lease obtained and lease expired. That is when I sent out that DHCP request, and when I accepted it and said, yes, I'm going to use this. And then how long is it good for? This is a very short lease. Typically, leases in most networks are good for a week, and after the lease is about halfway up, that's when your computer should start requesting a new IP address, and usually the server is just going to give you the same one, so everything keeps working. The gateway that I'm connected to, again, it's .2. The DHCP server, the one that gave me this IP address, its address is there, and I could check to make sure that that's legit. Again, some IP version 6 stuff we're not interested in. My domain name server, that is, what is the computer that maps names to IP addresses. All of that information I get when I do IP version 6 all. Let's say that something's not working. Let's say I'm trying to connect to a website or a database, send an email, it's not going out. You know, that joke that I've told 1,000 times, right? How do you do IT work? Have you tried turning it off and on, right? Because off and on is the easiest way to reset everything. One of the common things that it resets is your IP address. That is, it requests a new IP address, a new lease. We can do that manually from the command prompt. So if I do IP config/release, it's going to send a message to that DHCP server saying, hey, I don't need this IP address anymore, I'm done with it. And now if I do IP config/all, you see, oh, I don't have a regular IP address. Notice what I do have. I have one that starts with 169.254, right? That is a PIPA, which we've talked about in class before, right? Automatic IP addressing. That is a built-in thing for Windows that if you don't give it an IP address and it can't find one, it'll send out a message to everybody saying, hey, I'm going to use this one. Is that okay? And if nobody responds, it uses it. So that way, no matter what, there's some IP address and things can function on a basic level. Although we can't get out of the network and we can't really do anything that we probably need to do. So that's not going to be acceptable. We can always identify a PIPA addresses by that 169.254, right? If your address starts with that, something's wrong, right? If I need to get a new address, then ipconfig/renew will send out that same request message, right? Saying, hey, anybody have an IP address for me? And I should get a response from that same server. And we see here that I did, right? And now I'm 172.16.44.140. And if I go back and look at everything again, we can see everything is the same. It gave me, let's see, did it give me back the same IP address? Let's scroll up. Yes, it gave me back the same IP address. But there, my lease had been attained at 9:37 a.m. Now my lease has been attained at 10:27 a.m. Right? So so I have a new lease. And it is good for a half an hour, a very short time period. I think because this is a virtual machine and this is a virtual network, it has a very short update period because these machines probably get turned on and off all the time. But other than that, everything is the same. Everything is good to go. So what I want is for you to have kind of a mental picture of where everything is in the network. So my IP address is 172.16.44.140. So if we put that on my network, okay, so that's my IP address. This also tells me my DHCP server's IP address is 172.16.44.254. And that'll be this server over here. Those of you who paid attention in subnetting should know that is the last available address on the network. My gateway is 172.16.44.2. And remember, that is the IP address of the port, the connection to this network. The connection that leaves this network on the other side of that router, that has another address that I don't know. I don't need to know it. And my DNS server has the same address. So in this case, this router is acting as my domain name server. So when I give it a name, that's what's going to tell me the IP address that goes with that name. If I wanted to test my network to see if things are working, the most common tool I would use would be ping. So the first thing I always ping is my gateway. If I can't ping the gateway, then I'm not even communicating on my own network. And that eliminates a lot of problems. I don't need to worry about anything else. I'm not on my network. So it might be a physical connection issue. It might be, an issue with things being blocked. It might be an issue with my network address being out of date. But I'm not on my network if I can't ping it. Here I can, so everything's okay. The next thing I would do is I would always ping Google. And see, I am getting response back from Google. So that's traffic that's leaving my network, going across the internet, getting to Google and getting back. So everything seems to be working fine. If I couldn't ping Google, but I suspected it might have been a DNS issue. That is, it's not that there's an issue with the network, but I'm not getting a name, or excuse me, I'm not getting an IP address for that name. Then I would try ping 8.8.8.8. That is Google's domain name server, and it's just a number on the internet that I know by heart, right? And we see that I have 100% connection, so I have no problems. If any of these failed and I wanted to see where in the process they were failing, I might try Traceroute. Now, what Traceroute does is it sends a series of pings, but each ping has a time to live of 1 hop. The first one has a time to live of 1 hop, and then 2 hops, and then 3 hops. When the ping runs out of its time to live, whatever device has it will automatically respond. So it'll allow us to trace a path from where we are to where we're going. Now, pinging my gateway is useless because it's only 1 hop. But if I ping, or if I trace route www.google.com, so now it's going to tell me, all right, now it's going all the way to the Google website. The first hop is always going to be your gateway. The second hop is the first router after your gateway. And I'm not getting back a response, which is also not super uncommon. Sometimes these routers have ping turned off for security reasons. So Traceroute might not always get me what I want, but if I have multiple networks within my network, it can be very useful. Let's go ahead and let this finish up. Okay, so this didn't provide us as useful information as I would have liked because everything is blocking ping on each intermediate hop. It does tell us that it is 10 hops between us and the Google server. Just for the sake of completeness, I'm going to try the same thing with 8.8.8, but I expect to get a very similar response. Okay, yeah, again, very similar response. The only information I got is that I know it took 10 hops. But this is a really useful thing. So if a user, say, couldn't reach Google through their web browser, we know that we have connectivity with them, so there's some other issue. That's why we use ping and traceroute, is they eliminate possibilities and allow us to focus on on what really is wrong. So I hope you can use these new tools in your troubleshooting toolbox, right? ipconfig, check your IP address, make sure things add up, right? Check who's giving you your address. Make sure the person who's supposed to be giving it to you. Release and renew, reset the whole thing. That's the same as turning it off and on. Ping and traceroute just to show basic connectivity and let you know if the problem is somewhere else. If you have any questions, let me know.